In this video, I'm going to show you how to do the upside down birthday cake method. The upside down birthday cake method is used for a lot of things. In this particular video, I'm going to show you how to do the GCF. This video will kind of give you the baseline of how to do the upside down birthday cake method. So the first thing you do when you do the upside down birthday cake method is you're presented with two numbers or three numbers. You're going to make an L, which is kind of a layer of the cake. You're going to put your two numbers side by side. Then you're going to go to your divisibility rules and work through the numbers that go into both. Knowing your divisibility rules, you know when they end in 0, the first number we can take out is 10. So you put this common factor on the outside or the left of the birthday cake. So when you're doing that second step, you're looking for those common factors. The common factor in this one is 10. So you're going to make the bottom layer, you're going to take 10 divided by each. So 90 divided by 10 is 9. 150 divided by 10 is 15. It looks like we still have some common factors, so we need to continue working. So you make another layer of the cake. And 9 and 15, if we check, 2 doesn't work, but 3 works because 3 goes into 9. When we add 1 and 5, we get 6, and 3 works for that as well. So we're going to put 3 on the outside of our layer. Again, we're going to divide. 9 divided by 3 goes in there 3 times. 9 goes into 15 5 times. And since these are both prime numbers and they don't go into each other, that's the bottom of our layer cake. So to find our GCF, what we need to do is we look to our numbers on our left. The numbers on our left would be our 10 and our 3. The 10 and 3 we then multiply to find GCF. So 10 times 3 is 30. So our GCF of this one is 30. Oops. You can also do this, if you didn't know that 10 was a factor that you can take out, you can do the layers with other numbers too. So if we did 90 and 150, let's say we didn't know 10 with the trick with the 10 and the zeros, and we just saw the 2 since they both end in zeros. So we're going to put a 2 on the outside, and 90 divided by 2 would be 45. 150 divided by 2, 2 goes into 15, the closest one is 7. What's left over is 1. 2 goes into 10 5 times, so then we have 45 and 75. Looking at your divisibility rules, you'll see that 5 is the next one that goes in easily. So we'll put a 5 in here. 5 goes into 45 9 times. 5 goes into 75. We have to divide it into there. 5 goes into 7 1 time. We're left with 2. 5 goes into 25 5 times. We're left with 9 and 15. Again, looking at your divisibility rules of 3, we can use 3. 3 goes into 9 3 times. 3 goes into 15 5 times. Again, finding the GCF, if you did it this way, you're still going to multiply across. You're going to take 2 times 5 times 3. 2 times 5, you know, is 10. 2 times 3 is 30. So our GCF is still 30. So if you did it either way, you still come up with a GCF of 30. Let's do it with another problem. Let's try this one with a different problem. So we have 182 and 60. Remember, our first step was we make an L. So 182 and 60. Again, we're looking for common factors using our divisibility rules. So 2 and 0, we know 2 is going to go into there. All right, 2 goes into 18 9 times. There's no leftovers. 2 goes into 2 once. Now you're taking 2 into 60. 2 goes into 6 3 times. 2 goes into 0 0 times. All right, are we done? Let's check our divisibility rules. All right, 2 won't work because they're end number. Will 3 work? 9 and 1 is 10. 3 isn't going to work. On this one, 4 won't work. 5 based on the end number. 6 won't work because 2 and 3 won't work. 7 won't work. 8 won't work. and 9 won't work because of that rule. All right, since there isn't any other common factors, our GCF is simply 2. This is the last example, and I'll give you some steps as we go along. Step 1 is make your L with the numbers. And this works for one number, two numbers, not one number so much, two numbers, three numbers, four numbers, five numbers, however many numbers you have that you want to find a GCF of. So we're going to put our two numbers in there, 36 and 60. Our next step is to use the divisibility rules to find common factors. So using our divisibility rules, we can look at starting with the top of our divisibility rules, looking at that back number. We know that 6 and 0 are both divisible by 2. So we have a common factor. Step 3 is to divide all numbers by the common factor. So we're going 2 into 36, so we're going to go 2 into 3, 2 goes into 3 once, we have a leftover of 1, 2 goes into 16, 8 times. Going into 2 going into 60, 2 goes into 6, 3 times. No leftovers, 2 goes into 0, 0 times, so we're left with 18 and 30. Again, we can use our 2 because of our back numbers, so we'll make another layer. Put a 2, 2 goes into 18 9 times, 2 goes into 30, 2 goes into 3 once, we have a leftover 1, 2 goes into 10 5 times. 2 no longer works. Let's look at our other rules. 2 doesn't work, so 3 is the next one we try. 3 goes into 9. When we add the sum of 1 and 5, you get 6, so 3 is going to work. So 3 goes into 9 3 times, 3 goes into 15 5 times. Since these two are both prime numbers and they don't go into each other, we have to stop. So step 4 would be repeat until no common factors. And like I said, this can work for a lot of different things. This particular video as GCF. These would be your basic birthday cake methods right here. So that's how you would start all of your birthday cakes and continue your birthday cakes. The difference is how you end them. To find the GCF, remember at the beginning of the video, we circle the numbers on the left and we multiply them. 2 times 2 times 3. 2 times 2 is 4. 2 times 3 is 12. Thanks for watching.